So today we have a matrix and we want to count how many cells that submatrices that start with top left corner are have the sum less than k. So there can be many of them, and the solution is just to go row by row, calculate the sum, and then we can reuse this previous sum. So imagine we have this cell and we know the sum of this entire submatrix, and to count for the next cell we use the previous, maybe I'm wrong. Let's imagine it like this. We count in the next row after the known. So the next row, next cell is the current sum, the previous sum, its previous top sum, and also the previous left. The previous left is this one big. Previous left sum. And after that we have an overlap between them. So this is entire square is overlap, and the coordinates are, so the overlap is y minus 1, x minus 1. So this is a sub prefix sum. Equation. So the current sum yx equals previous top. So the previous top is y minus 1 x plus previous left yx minus 1 and minus overlap. The overlap is prefix sum of y minus 1 x minus 1. So this is entire formula, and then we have to check if it is less than k, and then we're done. The solution is O of m n, so the entire matrix should be checked. However, we can have a little optimization. It is possible. So imagine we have cell that is known that is bigger than k. So all the right cell, or all the cells to the right, would be like this, and we don't have to inspect them, can just break. And also the coordinate is the limit, and we can update it for the next row. We don't have to check the next cell also, it would be just a limit. So that means for each row we count from 0 to limit, and initially the limit is here, and then it goes like staircase, and this would be optimization, but still the solution is O of n times n. So let's look at the code. This is my accepted Kotlin version. I wrote it from the start with some golfing in mind. Just use sum of and count, and that's it. Now let's look what we can do with this. So the final version of Kotlin is the same. I also use a little trick of checking the both values x and y not zero by multiplying them. Now let's look at the Rust solution, and the Rust is kind of allowed to do some interesting things like use itertools, and the product allows us to make it short version, but the method of the function is the same. Now if we want to a little bit optimize it, we can introduce a variable that counts some of the current row, not the entire submatrix. And this sum is useful for to not write much boilerplate code. So this is what it looks like. Also use this Boolean operation as I32 as so to not write if, but it is the same. And it's also 0 milliseconds time. That's it for today.